Hi students, welcome to Science Extension Module 3, the Data, Evidence and Decisions. This is video 13 and the first in our specific look at some of the statistical tests that you might be using with your data. So you want to be able to apply appropriate statistical tests of confidence to a data set, including but not limited to the student's t-test. So firstly, the student's t-test isn't usually called the student's t-test these days. It tends to be referred to as just the t-test. And there are a couple of different types that we're going to be looking at. And the main use of a t-test is to determine to what extent the mean of a given set of data represents that of a normal distribution. Often we're looking at a subset or a sample of a wider population. We want to see if that subset represents that wider population. Sometimes we look at interventions to see whether there are meaningful differences between two means or two averages for two different groups. So sometimes you might be looking at the comparison between the scores in two different classes, and you want to know whether there's a significant difference, statistically significant difference, in the mean of those two groups. The general null hypothesis that you're planning to use will therefore be the mean of group 1 is equal to the mean of group 2. That is, no difference. Remember, our null hypothesis is about there being no difference. So when we construct the null hypothesis for our t-test, we're saying that the two means will be equal. Probably the most tricky thing that you need to do when you're applying the t-test is to decide which type of t-test you're after. There's the one sample t-test. The one sample t-test is used when we want to know whether our observed data meets our expected data. Now that might sound a little bit similar to what we're going to be doing with our chi-squared test, but really it's more about we think there's this population which has a certain mean, and we've got this little subset. We want to know whether this subset is basically has the same characteristics as our wider population. So it's just one sample, and that's a one sample t-test. The rest is when we've got two different samples or two groups that we want to compare, and the determination of whether we use the paired or the unpaired will hopefully be obvious as we go through these. We use a two-sample t-test to determine whether two sets of data are both drawn from the same normal distribution. But the unpaired t-test is used to compare the means of two groups for the same variable when the test conditions for a second have been altered. So an example of this might be, do men in the same industry earn more than women in the same industry at the same level? So that idea of a gender equity gap in terms of pay, is that a real thing? Statistically, is that a real thing? Or is that a perception? So we could use an unpaired t-test. We look at how the means of each of these two compare and whether they're statistically significant or not. For a paired t-test, the paired t-test is used to compare the means of two groups for the same variable when the test conditions for a second variable have been altered and undertaken by the same group. So one of the things that's important here is that we have to make sure that both groups, when we're talking about paired t-tests, that the same group has undertaken two different conditions. So the easiest thing for that is if you've got the same students taking a series of tests but undergoing some sort of a change. So students on a beep test, do they perform better early in the morning or after 10 a.m.? So it's the same group doing the test, so you can compare their results before 10 a.m. and after 10 a.m. In the paired t-test, we really are looking at an entire group that our sample has gone through, if you like, condition A and then condition B. So that's when we would use our paired t-test. So with any of our statistical tests, you need to calculate a test statistic. So that's the number that basically is spat out by the computer when you put all of the information in. So you can just quickly find the test statistic in something like Excel by typing this thing in. So it'll be an equals if you're going to write a formula, but in some of the other applications, it may not need that. The t-test is about the range of values. So you'll have a range which will have a series of values, and that'll be group 1. And then you'll have a second range, and that'll be a group of values, and that'll be group 2. And that may be a before or after, or it may be men earning salaries and women's earning salaries. And then we're talking about two different types of things that are usually part of this as well that you need to think about when you're doing your t-tests. The first is the tails. You're going to have one or two tails. So you might be looking at determining whether or not a particular mean is higher than another. So that's a one-tailed test. Okay, we're only interested in whether the mean is higher. In a different situation, we might be interested in whether there's a difference. Could be higher, could be lower, don't know. But I'm interested in whether or not the two are overlapping or whether they're from two different kind of groups. And so therefore I might be looking at a two-tailed test there. So I'm interested in, if you think about the way that our bell curve works, I'm either looking for just one tail or I'm looking for both tails, a value that's higher or a value that's lower. So that's 1 or 2. The type is what we talked about before. So the type of t-test is around about our one sample t-test, our unpaired t-test, or our paired t-test. As I've mentioned, you can go through and manually calculate all these yourself, but that's a bit of a waste of time, and nobody would do that these days, not with the computer power that we have available, and also with a huge range of statistical programs. If you've got your data set, you put them into a program, it gives you a whole lot of data. And here's an example that we've looked at previously. I've used Excel to generate this data. The data has come via a series of values that we looked at in calculating, or at least in counting, the number of different colors of M&Ms, putting them into a table, and then using the statistical program that's available in Excel to generate an output like this. So let's actually walk through this. So for example, here is an Excel sheet that shows some of our values for our M&M bags. So you can see 4 different bags were counted for the number of red, green, blue, yellow, brown, orange M&Ms in each of those bags. So we've recorded all of those values as raw data. What I can do is I can say, well, let's look at the mean number of red compared to the mean number of yellow. Now you can see when I look at these values, I've got the totals, which is a bit of a clue here, 178 red in total for the 4 bags, only 88 in total for the yellow bags. So that would suggest to me that maybe there is a statistically significant difference in the mean number of red M&Ms compared to yellow M&Ms in a bag. Could I use a t-test to actually confirm that? Well, yes, I can. So what I'm going to do is I'm going to leave the display on there at the moment, and I'm going to come up to where my data is, and I'm going to use my data analysis tool. So remember, this is an add-in that you have to put into Excel if you're going to use some of these tests, but it's fantastic, gives you a really nice way of being able to do all of these steps in one hit. So let's do this. Let's go with the data analysis. And again, you can see I've got a range of different tests that I can look at. When I come down to my t-tests, I have a paired 2 sample for means, a 2 sample assuming equal variance, and a 2 sample assuming unequal variance. Because they've come from the M&M factory, I'm going to assume that they've all come from this big pool. One of the things that's worth playing with sometimes is to look at the values for a 2 sample assuming equal variance and a 2 sample assuming unequal variance. But I'm going to go with the equal variance. So let me go OK. Now I haven't selected anything yet, and you can see now it's asking me for my range. So variable 1 range. Now the nice thing about these formulas is I can do the typing, or I can click these little boxes and it actually allows me to select them. So here's my red sample. So I'm going to take these 4 values for my 4 red counts, and then I'm going to go to my second variable. So I want to compare the yellow ones. So let me take these ones. So that's there. Now you can see the hypothesized mean difference. So I'm testing the null hypothesis. So I'm going to have a hypothesized mean difference of 0. So I'm going to try and see if I get a statistically significant result based on whether or not there is no difference between each of the means of these two groups. You can see my alpha level is already set. The default is 0.05. I'm going to leave that there, but I want you to see this. So I'm actually going to have an output range where I select that. So I'm going to again come to my spreadsheet. I'm going to just pick one. Maybe I'll just go down 1, and I'm going to pick that. And then I've got my output. I'm just going to click OK. When I click OK, it tells me my two t-test to sample, assuming equal variance. You can see here are my two variables. You could actually change this. So again, this is a data cleansing thing here. You might actually change variable 1 to red and variable 2 to yellow so that you can track some of these more easily. You might want to also do something with the number of decimal places, but those are again just ways of tidying up the data so they're easier to present in your report. What you can see is my total number of observations in each one. The degrees of freedom is n-1 for each of the groups. So it's 4 samples for each of the two groups. 4 minus 1 is 3. So 3 and 3 is 6. So that's my degrees of freedom that I'm actually using with this particular test. And you can see my test statistic. And this is one of the reasons why the test statistics in and of themselves, you could manually calculate these, but unless you have a table, it's a bit of a waste. It doesn't really help. This program takes that t statistic, it has the table with all these values in it, so it can then give me a one tail and a two tail. And I was interested in the variation, so I'm going to have a look at my two tail test. And very, very obviously, this is a significant difference. It's well below the 0.05 threshold. So if my alpha level, my significance level is 0.05, I have 0.0002. That's way below. For comparison, let's maybe do exactly the same thing, but let's do it with two we think are a little closer. So let me look at red and green, for example. So if I go back to my data analysis, I'm going to use exactly the same test. I'm going to this time, I can keep my variable 1 the same, but this time my second variable, I'm not going to use the yellow, I'm going to use the green. The rest is the same. My output range next to this one, so it's going to sit in this spot here. And then I can have these two together. So let's have a look at what happens this time when we compare the red and the green. So you can see this time my variable 1 is still red, my variable 2 is green. The mean of the two groups is much closer together. You can see the variance here. So we've assumed equal variance. That was pretty close for my red and my yellow, not so much here. So this is where you might want to play around with some of these tests. Same number of observations, and you can see my pooled variance is slightly different because I've got two different samples this time. I've still got a hypothesized mean difference of 0 and 6 degrees of freedom, same number. But you can see this time when I'm looking at my two-tailed test, again, I'm looking to see whether they're higher or lower. When I do the comparison, it's 0.07. Now, even with the one-tailed test of 0.03, rounding up to 0.04, that's kind of there. It depends how you set your null hypothesis up as to whether you're going to accept or reject these. This is part of t-tests, but on the basis of a two-tailed t-test, is there a significant difference above or below? On the basis of this, I would accept my null hypothesis for the red and the green. That is, there is no significant difference in the means of these two groups, even though one's 44.5 and one's 37.5. Significantly not different. 44.5, 22. I would reject the null hypothesis for the red and the yellow. These ones really are significantly different. So you can see these are the values that we've put here for you with the screenshots of how we do these calculations and where they go, and you can see the values that have come up. And the difference between the red and the yellow in this situation, a stark difference when we look at the mean of the two groups. So we don't think this hypothesized mean of 0 is actually going to be supported, but we need to make sure that we have a look at our p-values in order to determine whether or not we're going to accept or reject our null hypothesis. And in this case, very clear result for these, very, very significantly below our 0.05 threshold, and therefore we're going to reject our null hypothesis and actually say there is a difference. And we can also, in this situation, say, I think the difference is that there are more red than yellow. So if you buy a packet of M&Ms, you should expect more red than yellow. Just to quickly clarify those parameters again for you, we use, when you're looking at some of the calculations that you carry out in Excel, and there is a statistical function in Excel that allows you to calculate a test statistic based on the t-test. You might have to determine or put a number down, which is going to be 1 for a one-tailed distribution, in which case we're only looking for whether the values sit above the mean or below the mean, or a two-tailed test if we're looking for both. Are these values are we considering the whole range of values in this situation? And if you're using the test in Excel that's not the one that I just had a look at, but the simple one that just generates the test statistic, you need to pick a number type as well. So 1 for a paired t-test, 2 if the type is equal variance, and 3 if you've got unequal variance. So a little scriber, there's some nice little visuals that you can find for a lot of these statistical tests there. And you can see our paired sample t-test where we're looking for a difference within a group between 2 different points in time or 2 groups doing different things. An independent samples, which is the unpaired, and that's basically when there's a difference between 2 groups, such as the earning capacity of males and females. And then a one sample test when we're looking to see whether or not the sample that we're investigating is representative of a wider population. One other quick word about the t-test. There's a couple of assumptions that you need to be aware of if you're going to apply the t-test to your data. The first one is how you select your data. So you need to make sure that the selection of data is independent. We also want to make sure that we are randomly assigning subjects to different things. Now, of course, that's going to be maybe a little more difficult if we want them to, if we were interested in a paired t-test. So we want a group, once we've got our randomly selected sample, we're going to allocate them to the A situation, and then the B situation, we are going to keep them the same. Our distribution, we do want to make sure, or one of the assumptions we make with our t-test is that we're drawing from a normal distribution. If the distribution is skewed, it may affect the results a little, and that may affect the confidence you have in the conclusions that you draw from your data. There's a assumption about variance too, that there is a homogeneity of variance or homoscedasticity, and that basically means that the sample that you're looking at has come from a population that has a similar variance. So we're looking for consistency of variability, variance, standard deviation between our different groups, whether they're 2 different groups, the same group at 2 different points in time, or a subsample of a wider population. Because of the nature of the calculation, and even for something like our little example with the M&M packets, 4 isn't very many, so it's a pretty small sample size. So we do need to be aware of the fact we've found a very significant difference in the results, and that's great. That's a nice story to tell when you're doing your write-up, but you do want to make sure that you would mention something about that low sample size. This is one of the reasons we give you lots of time to go through, collect lots of data. It really feels like when you've collected enough, go and collect some more. Because the more data you have, the more confidence you can have in the conclusions that you're drawing, and low sample sizes can significantly limit the generalizability of your results and the confidence you can have in the statistic that you calculate, in the probability value that you determine from that test statistic, and then the conclusion that you draw about your null hypothesis. It's worth having a bit of a play with the t-test, just with some random data like the M&M data that we've got, so that you get so you get a little bit of practice at using this test so that you can use it confidently with your own data. Thanks for watching.